Hi, in this video we are going to learn how to graph a linear inequality. And to do this, you really should know how to graph a linear equation first. So the first step is to graph the line. And what we're going to do here is basically pretend like it is an equation, like there is an equal sign there instead of the inequality symbol. But we're going to have to remember that different forms of linear equations call for different steps to graph them. So if we see something that's in standard form, we want to plug 0 in for x. That will get you your y-intercept once you solve that out. And then plug 0 in for y and solve for x, and that will get you your x-intercept. But when we're doing things on delta math, if we don't get integer or whole numbers for our intercepts, it's not going to let us plot them, and that's pretty annoying, but we have a backup. We are going to convert this standard form into slope-intercept form, and we do that by solving for y. Okay, so let's talk about slope-intercept form. That is what looks like y equals mx plus b. Right? So you'll know the y-intercept, that's easy to graph, but then you're going to use that slope to go either up or down and over however many you're going to go, and that's going to get you one other point, and then you will have the points for your line. The second step is to actually draw in the line. The difference here is that we may not have a solid line. If we have a less than or a greater than symbol, we're going to put a dashed line, something like this. If we have a less than or equal to or a greater than or equal to, then we are going to graph a solid line like we normally would. And the last step is to do some shading. So this is the new part, right? And if something's in standard form versus slope-intercept form, that really affects what I do. However, you could use this method that I'm going to go through on standard form for both of these forms. So my suggestion to figure out where we're going to shade a region, we are going to plug in what I think is the easiest thing to plug in, 0 for x and 0 for y. And we're going to test out that inequality and see if it makes it true or false. And if it makes it true, we want to shade the region that contains the point that we plugged in this case, the origin. And if it made it false, we want to shade the other region. We don't want to contain it. And that's because this shading, what this shading is doing, right? Let's say I had a line that had something dashed like this. If I shade this region, what that says is that all of the points in this area make the inequality true. Whereas with an equation, it was just points on the line that made the equation true. So inequalities have a lot more points that will make it true. Okay. One other thing is that if we see slope-intercept form, there is a bit of a shortcut that I like to use. And since it's already solved for y, we can see exactly where to shade if we just look at the direction of the inequality. So if the y is less than whatever the other side is, that's going to be shading below the line, like I did on this picture up here, that's below. But if the y is greater than or equal to the other side, that's going to be shading above the line. In this case, that would be here. Okay, so we're going to switch over to delta math, and we're going to do some examples. All right, so here we are. Our first example, we need to make some observations about the form or the structure of our equation. So notice that we have one of the sides that already is where y has already been isolated. This is slope-intercept form. So that means that 3 is our y-intercept. So I'm going to click on 3 to get that going. And that 2/5 is our slope. So we start at our y-intercept, and we use the 2 to go 2 up from there, and the 5 to go 5 spaces to the right. That's using your slope, to find another point. See how my slope here is now up 2 over 5. All right, so once I got those 2 points on there, you'll notice that the line was automatically a solid line. You have the option here to change it to dashed if you'd like. But let's take a look. What should this one be? Our inequality is a greater than or equal to. Equal to means we're going to leave that solid, right? Because that means that points on the line are part of the answer. Now we have to do our shading. So we have this other button here that allows us to shade either below or above. So in this case, y was greater than. That means we're going to shade all of the y values here that are greater than this line. So that would be it for that example. All right, so here's another example. This time I picked one where the form is different. This is in standard form. And we might want to try to find the x and the y-intercept first. If you try to find the x-intercept, that means you're plugging in 0 for y. This disappears. And now you would be solving the equation negative 3x equals negative 8. If you were to then divide both sides by negative 3, you wouldn't get a whole number. So that is not going to work out for us. So that means we need to do a little conversion here. We want to go from standard form to slope-intercept form. All right, so we need to solve for y. So let me get this written down. We have negative 3x plus 2y is greater than negative 8. Oops, that's a negative 8. Okay, so our job is to get y by itself. We're going to start by moving the negative 3x over to the other side. And we're just going to treat this inequality symbol like an equal sign for now. So I'm going to add 3x to both sides of this inequality. So now we have a 2y on the left. This is still a greater than. And I'm going to write the x, the 3x first here so that it looks like a slope-intercept form, and then the minus 8 at the end. We are not done yet. We want to get y completely by itself, so that means we still have to get rid of this 2. Those are being multiplied, so we would undo that with some division, right? We're going to divide everything by 2. That gets us the y on the left. We divided by a positive number, so our inequality symbol stays the same. And now I'm just going to simplify this. 3x divided by 2, well, that doesn't simplify. 3 over 2 is just the same thing as 3 over 2. I'm just going to move the x to the side here. And now I have to do negative 8 divided by 2, which is negative 4. So we went from standard form up here into slope-intercept form down here. So that's what we're going to graph. We have a y-intercept, right, at negative 4. And our slope is 3/2. So we're going to graph that y-intercept first, then go up 3, right 2. Here we go. Y-intercept at negative 4, up 3, and right 2 brings us up to a point right there. Now, we have an inequality symbol that does not have an equal sign here. We don't want to include the line as part of our answer, and we do that by clicking change the line to make it a dashed line. Last thing we need to do is do our shading. Let me switch back here. You'll notice that we had y is greater than, and that says that we're going to shade above. I'm going to do one more thing here to show you the other way of checking the shading. I think that's important. So we know how to do that when we need to do that. Okay, so if we want to check the shading, we can plug in 0 for x and 0 for y and see what happens. I'm going to actually just plug in it up here to show you, because this is typically where you would do it in standard form. So I'm putting in the 0 for x and the 0 for y. And we're checking if this works. So let's do our simplifying here. Negative 3 times 0, that's 0. 2 times 0 is 0. We get 0. Is 0 greater than, negative 8? It is greater than negative 8. Let's see if I can just write the negative 8 better there. There we go. This is true. Right? This is a true statement, which means that we want 0, 0 to be in the shaded region. Okay, so let's go back and make sure that that's in the shaded region. But remember, this also said that we were going to shade above the line. Here's 0, 0, and look at that. It's above the line. So everything works out, and that would be our answer for that one.